So today we're going to talk about surface area of prisms and cylinders. You should learn to find the surface area of a prism, and then we're going to teach you how to find the surface area of a cylinder. And since this is our first unit on surface area, there's a lot of background information that we're going to have to go through as well. So let's go ahead and get started. First of all, let's talk about the basics of what a prism is, because we haven't defined this yet. So a prism is a polyhedron with two congruent parallel faces, and we're going to call those faces bases. Okay? And then the other sides of that 3D figure are called lateral faces. So if we're looking at like this prism right here, we have a pentagon up here and another pentagon up here, down here, and those are our two parallel faces that we're going to call bases. Okay? And when we're talking about them in formulas, we're going to use capital B for the area of that base, but we'll get to that later. And then the other faces are all rectangles, okay? And that's something that you'll see with prisms, is we kind of take a base, and I don't know if you've seen an extrusion machine, but think of a Play-Doh fun factory, and we kind of squeeze that shape through the Play-Doh fun factory, and we get a noodle in that shape. And so the prism is kind of like a really short Play-Doh fun factory noodle. Yeah. Okay. Yeah. So it's called an extrusion type process, and it creates this prism. But anyways, all the lateral faces are all going to be rectangles. Okay. You can see that here with this triangular prism too. Still, all our lateral faces are going to be rectangles. So there's two kinds of prisms. One is called a right prism, and one is called an oblique prism. Basically, a right prism is one that stands straight up with no slant to it, and an oblique prism is one that has slant to it. So let's come back to that after we talk about altitude and height. Now, the altitude of a height is the perpendicular segment that joins the planes of the bases. Now, if those bases are right on top of each other, the height is also going to be this edge distance here. If it's not, then you might have to do Pythagorean theorem type stuff with that to determine what the height is as it differs from the distance or the length of that side segment. Okay, so if we go back to our two kinds of prisms, a right prism is one in which the lateral edges are also altitudes, and an oblique prism is one in which the lateral edges are not altitudes, and that happens because it's slanted. So the height of a prism is the length of that altitude, okay? And remember that the altitude may be the length of that lateral edge, or it might, if it's a right prism, and if it's not the length of that lateral edge, then it's not a right prism, okay? So let's talk about surface area. First of all, we can use a net to find what surface area is. And surface area is the area of all the surfaces of a solid. So a net is a good way to picture this. So here we have a hexagonal prism, okay, two hexagons, and if we unfold the net, we have our two hexagons, and then all these sides kind of correspond to the edges that roll up into that hexagonal prism, okay? So if we want to find the area of the surface area of that solid, we can find the area of each of these little segments of that net, and then we can add them up. And we see that two of them are going to be the same, and then these six are also going to be the same. So if we were going to say this area here was 6 centimeters squared, and this area was 4 centimeters squared, and I'm just throwing in random numbers here, then I would have 2 times my 6 centimeters squared plus 4 times my, plus 6 times my 4 centimeters squared. And that would equal my total surface area, okay? So that's going to be 12 centimeters squared plus 24 centimeters squared, which will equal 36 centimeters squared. And what I've done here is I've taken my area of my bases, so I've got two bases, and then this area here, the area of my lateral faces, we're going to call my lateral area. So the surface area of this prism is going to be 2 times the area of my base plus my lateral area. And we're going to see that formula repeated again here on the next slide. So that net method gets old pretty quickly. So if we break our surface area into two parts, we have the area of our bases and the area of our side surfaces, and we see a little bit easier formula develops. Because if I think about it, since each one of these side segments corresponds to another side segment, right? Then the length that I've got here is really my perimeter. And this distance here is my height. So my lateral area is, because this is a rectangle, is just going to be my perimeter times my height. Okay? And my surface area takes my lateral area and adds the area of both my bases to it. So I get surface area equals my lateral area plus 2 times my base. My lateral area is just my perimeter times my height. So 2 times my base. So there's two different little formulas that we could use for surface area. Either one works great. They both mean the same thing. You just have to remember that what lateral area means if you're going to use this top formula. Now let's talk about surface areas of cylinders. Cylinders have similar properties to prisms. They have two parallel bases, but in this case, instead of being able to use any polygon, we use only a circle as a base. Now, altitudes and heights still have the same properties, and we're going to only deal with surface area with right cylinders, not oblique or slanted ones. Okay? So, my lateral area is going to be a little bit different here. See, if I look at my net of this here, I've got two circles, and this rectangle is that whole side portion right here, that whole side thing unraveled, okay? And so the length of this rectangle is equal to my circumference, which is 2 pi r. And then this is my height, so my lateral area is going to be 2 pi r times my height, okay? Which if I substitute in that my diameter equals 2 pi, or 2 pi r, sorry, my diameter equals 2r, then I can also use that lateral area equals pi dh. Okay? So, now let's look at surface area. Surface area is my lateral area plus 2 times my base, right? Because we have this area here and then the area of my two bases. Okay? So, 2 pi r times my height is my lateral area, and then 2 of my pi r squared is the area of my bases. So, my surface area is just 2 pi r h plus 2 pi r squared. Okay? So now let's do some example problems. Let's find the surface area. So remembering that surface area equals lateral area plus 2 times the base, right? Now my base formula, remember I said I was going to use big B for the area of my base. In this case is going to be, because we're dealing with a polygon, is going to be either 1/2 AP or my favorite formula, ASN over 2. Okay? So each of these prisms will have a different area formula. So if it was a triangle, I would use 1/2 base times height. If it was a trapezoidal prism, I would use the trapezoid area formula for B. Okay? Now my lateral area is just going to be my perimeter times my height. Now we can see right here, this is my height, and my side length, my perimeter, is just going to be the side times a number, side length times the number of sides, right? So my side length is 12 meters, right? Times my number of sides, which is 6, times my height, which is 6 meters, plus 2 times the area of my base. So now, we've been given an apothem, and that apothem is, looks like it's 4 meters, and my side length is 12 meters, and my number of sides is 6 over 2. So now we can start doing some math. So we end up with 48 times 3, which is the area of each of my bases is 144 meters squared. So 2 times 144 meters squared is going to equal my area of my bases. And so now we've got plus 288 meters squared, and 12 times 36, and 432 meters squared. So we've got a total surface area of 720 meters squared. Now keeping in mind, my lateral area is this part. Okay? So if you get asked a lateral area question, it's always that first part before you add the area of the bases in there. Now let's take a look at the surface area of a cylinder. Remember, we're still going to use the same formula. So surface area equals the lateral area plus 2 times the base. Since we're dealing with a cylinder, my lateral area again is my perimeter times my height. My perimeter is my circumference, so 2 pi RH. And my base is going to be pi r squared. So I end up with plus 2 pi r squared. So my radius is 4, so I have 2 times pi times 4 miles. This is one huge cylinder here. And my height is 9 miles plus 2 pi times 4 miles squared. Okay? So we're going to end up with 8 times 9, so that's 72 pi miles squared, plus 4 squared times 2 is 32 pi miles squared. So 72 plus 32 is 104 pi miles squared. Now, since this is a cylinder, we're going to keep it in terms of pi, okay? So we're going to keep that surface area in terms of pi. And again, if we were looking for lateral area, it would be that 72 pi miles squared. Okay? So what we've learned is, we've learned what a prism is. We've learned how to find surface area with our net method. We've learned what lateral area is. We've learned how to find surface area with formulas for prisms and for cylinders. Okay? So that's what we're doing with surface area. That's it for today.